All right, so the series, the geometric series 1 over 1 minus x is going to be used throughout the next couple of videos, all right? So you know already that this is 1 plus x squared plus x cubed plus dot 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 plus x to the n, right? And we already know, all right, we can do it right now, that let's say we do the general term, right? The general term is x to the n. So let's look at the interval of convergence and the radius of convergence, okay? So we have the limit, I'm doing the ratio test as n approaches infinity, of x to the n plus 1 over x to the n, which is just going to be the limit as n goes to infinity of just x, which is just the absolute value of x, right? The absolute value of x is less than 1. So, okay, we know that we need to test now. Okay, the radius is just 1 because there's 1 underneath here. Okay, so your radius is 1. Your interval, we're not so sure about yet. -1 to 1, but we have to test the endpoints, right? So if you test the endpoints, let's say we say x is -1. Then we'd have the series -1 to the n. Okay. Now, this series just oscillates between 1 and -1, right? This is oscillates. So, all right, it diverges. Now, if we look at x equaling 1, we just get the series from n equals 0 to infinity of 1 to the n, which you can just use the nth term test for divergence. The limit as n goes to infinity of 1 to the n, okay, is just going to be 1 to infinity, okay, which is not 0. So this diverges by the nth term test, right? So you don't gain any endpoints. So therefore your interval is -1 to 1. Okay, so pause the video and copy down this question. So we're going to find a power series for 1 over 1 plus x, centered at c equals 0. We're going to include the first 4 terms and the general term. Then we're going to give the radius of convergence and the interval of convergence. So remember, we have 1 over 1 minus x, which is 1 plus x squared, yada, 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 right? So here, when we have 1 over 1 plus x, it's the same as having 1 over 1 minus -x. So what we're going to do is we're just going to replace x with -x. So all the odd terms are going to become negative. And now we have an alternator. So we have -1 to the n times x to the n. All right, now you can either write this out as -1 to the n times x to the n, or we could write this out as -x to the n. Okay, those are the same thing. So as far as the radius of convergence, it's still the same, okay, because we didn't integrate and we didn't get a derivative. So the radius is still 1, and the interval would still be -1 to 1. All right, so let's say we want to develop this power series. Well, we already developed 1 over 1 plus x. So now all we would do is we would just multiply 1 over 1 plus x, right, which is this series here, we're just going to multiply this by x. So we get x over 1 plus x is just x. These just all go up a power. X squared, x cubed. Okay, but now look at what's happening. The even terms, I only want the first 4 non-zero terms. So the even terms are now negative. Okay, we still have our alternator, but now this is x to the n plus 1. Okay, that's the difference. So if you want to write this out as a series with the series notation, you'd have n equals 0 to infinity of negative 1 to the n times x to the n plus 1. Okay, copy down example 3 so you get the idea. I'm going back up here and I'm substituting in x squared every time I see x. So I have 1 over 1 minus x squared is going to be 1 plus x squared. Now x squared squared is x to the 4th. X squared cubed is x to the 6th. So we just have x to the 2n. It's actually x squared to the n, which is x to the 2n. All right. Okay, so let's start off. Let's just remind you that this comes from geometric, right? So right here, you know how you have the formula a sub 1 over 1 minus r. So remember, this is your r. So the absolute value of r is the absolute value of 2x. Now remember, that has to be less than 1. All right, so the absolute value of x is less than 1/2. So you can see here that your interval of convergence, it used to be from -1 to 1, but now your interval of convergence is going to be from -1/2 to 1/2. Okay, and your radius of convergence is just going to be 1/2 now. Okay, so your radius is 1/2. Okay, whereas before your radius was 1. Okay, so keep in mind, you could also do the ratio test if you want once I write the series out. All right, but what's happening is we're compressing by a factor of 2 horizontally. Okay, that's what's going on. All right, so let's write it out. So remember, we're going to replace 1 over 1 minus x. Each x term is going to be replaced with 2x now. So 1 over 1 minus 2x is going to be 1 minus 2x, right? Plus 2 squared is 4, so that's 4x squared. 2 cubed is 8. So it's just 2x to the n. All right, this one's going to be a little trickier. So we have 1 over 4 plus x centered at c equals 0. Now you remember the formula, s equals a sub 1 over 1 minus r. Okay, r can be a function of x, which is what we have here. So let's get this to resemble this over here. So I'm going to write this as 1 over 4 minus negative x, but I don't want that 4 there, so I'm going to factor that out. When I factor that 1/4 out, then I'll have 1 over 1 minus negative x over 4. Because if you distribute that in now, it needs to cancel out, right? Okay, so this is going to be your a1. So let's write it like that. So we have 1/4 over 1 minus negative x over 4. And this works because the center is at 0, right? So now let's write out our series. Okay, so the series is going to be starting at 1/4. Okay, so what you're doing is you're multiplying everything by 1/4. So remember, we had the series 1 over 1 minus x, right? Was 1 plus x squared, x to the third, x to the n. So we're going to replace x with negative x over 4. Then we're going to multiply everything by 1/4. So you could do this at whatever pace you want. So let's say I first do this. 1 over 1 minus negative x over 4. That would be 1. Then I'd have minus x over 4 plus x squared. And you have to be careful here, right? Well, let me just backtrack so you guys can see the work. So plus, this is negative x over 4 squared. And then negative x over 4 cubed, negative x over 4 to the n. So this becomes 1 minus x over 4 plus x squared over 4 squared. You can leave it like this. There's no reason to make it look any prettier than this. So you don't need to write out 1664. You can, but you don't have to. Okay, so now I'm going to multiply everything by 1/4. So 1/4 over 1 minus negative x over 4 is then going to become 1 minus, this is going to be x over 4 squared plus x squared over 4 cubed. See why I left it sloppy? Minus x cubed over 4 to the 4th. And then that's just going to be negative x to the n, okay, over 4 to the n plus 1. Now r, keep in mind, right, r, the absolute value of r, has to be less than 1. So less than 1 means negative 1 is less than x over 4, which is less than 1. So now we have negative 4 is less than x, which is less than 4. So you can see our interval is negative 4 to 4. And we could have seen our radius right here. Okay, the radius is equal to 4. Okay, this is a more difficult problem. We have the power series for 1 over x centered at c equals 1. Okay, first I'm going to do this the long way by generating it by using Taylor's formula. So we have f of x, 1 over x, right? F prime of x, negative 1 over x squared. F double prime, 2 over x cubed. F triple prime, negative 6 over x to the 4th. Now we're centering this at 1. So we have f of 1, f prime of 1, f double prime of 1, f triple prime of 1. Okay, I'm looking to give the first 4 general terms. So I get 1, negative 1, 2, negative 6. Okay, so Taylor's formula, we do 1 over x equals f of 1 plus f prime of 1 times x minus 1, because that's your center, plus 2 times x minus 1 squared over 2 factorial, minus 6 times x minus 1 cubed over 3 factorial, yada, 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 right? So the general term would just be, you can see that these are going to cancel out. So it would just be x minus 1 to the n. Now, the other way you could do this, which most people probably wouldn't think of, is you could write this as 1 over x is the same thing as 1 over 1 minus negative x minus 1. So what we could do is we could replace the values of x in 1 over 1 minus x we could just replace those with the opposite of x minus 1, and so you would get 1 minus, right, because the plus is now becoming a minus, x minus 1, and then you would get positive because you're squaring, so it would be x minus 1 squared. Then it would be negative again because you're cubing, x minus 1 cubed plus, and then you would, but then you would have, oh, I don't have the alternator up here, so this has to be negative 1 to the n. All right, good, I just caught that mistake. Anyway, so then we'd have negative, right, 1 to the n, x minus 1 to the n. All right, hopefully that helps. I think we'll end the video here. There's another problem, but I think it's just too difficult for kids to understand from a video. So I will go over that one in class. All right, thanks, kids.